You're all good to go.
Good stuff. Thank you very much, Matt. So today we're going to be talking about how you can use Microsoft Azure to build a data solution on top of Microsoft Dataverse or Dynamics 365, both the same thing, as I'm sure you know. So what we're going to do is we're going to first of all just set the scene in terms of looking at what are the challenges in today's sort of cloud-first world. You know, it very much feels as if we've got too much data hitting ourselves these days. So we'll look at, okay, why do you need to have a data solution on top of that to try and sort of get on top of that? We'll see how the Dataverse, how Dynamics 365 can fit in as part of that. We'll take a high level look at some of the various different solutions in the Azure Stack that we can use to build out our data solution. And then we're going to jump into a sort of a hands-on demo, hopefully a little bit interactive as well, so we can sort of see some of these tools and actions. Then we'll round off by sort of showing some of the bits that we didn't touch upon. And if we've got time at the end, we can answer any questions. Although if you have got questions or things like that, just let us know throughout, put them in the chat, and we'll try and get around to them as and when they come up. So a little bit about me on the slide there. I'm sure I know most of you who attended today, but my name's Joe. I'm Director and Principal Consultant at Solo Cloud Solutions. We're a small gold partner based in the northwest of England. And I'll hand over to Mark to introduce himself.
Thanks, Joe. So yes, I'm Mark Carrington. I'm the Chief Technologist at Databricks. We're a data quality solutions provider, ISV, particularly in the Microsoft Dynamics Power Platform space. But we're quite agnostic, and we'll work with people with Excel files and other competing CRM systems, which I'm not going to name today.
Yeah, I was going to name one of them. Let's just say they're getting quite a bit of slack recently, eh? Thank you. I'm here all evening, ladies and gentlemen. Okay, so data abundance in the cloud age. So, you know, as I've said already, it does feel as if, you know, we've got lots of, as businesses today, we have lots of different systems, all of which, you know, have data at the core of them. It could be that maybe these systems aren't tied together. You know, so although we may be rich in data, or it feels like we're rich in data, we might get a very poor return on that in terms of what we're getting from the business. So what are some of the things and challenges that arise as part of that? Well, processes. You know, how can we implement, you know, clean, effective processes, you know, not only just to store our data, to actually get it into a shape where we understand, transform it, link it with other data sets where necessary, linking together both on-premise and cloud systems. It becomes a real challenge when we start thinking about that in detail. You know, who's consuming our data? Okay, who in the business needs to see our data? Do we need to actually provide some insights to our customers as part of that? What type of devices are they accessing their data through? You know, there's a whole range of different challenges that we have to meet. You know, not necessarily, you know, we want to try and provide a one-size-fits-all approach, but that may not always be appropriate given the type of solution we're trying to build out. Variety, you know, so back in the day, you know, we just all we had to worry about was just, okay, if it's in a SQL database, we'll be happy, you know, we're going to get what we need. These days, we're in a situation where we've got both structured and non-structured data that we need to work with. So non-structured in the sense of maybe like image files, you know, maybe JSON documents in various different formats. You know, we no longer can sort of fit things in a strict sort of structured SQL model. We have to think outside the box and build solutions that can accommodate that. And ultimately, at the end of the day, you know, from a technology standpoint, it becomes quite difficult when we've got lots of different vendors, you know, such as Microsoft, AWS, G Cloud, Oracle. It becomes a bit of a challenge to, okay, how can we identify the vendor that's going to be best for us? Who's going to deliver us the most benefits? Who's going to be the most innovative? And who's going to be the most accommodating to our particular needs? So when we start to think of this in the context of Dynamics 365 or the Dataverse, you know, it really, you know, when it becomes really important for you to consider, okay, what is my data strategy and how am I linking in Microsoft Azure as part of this? You know, so as I said already, you know, you could be sitting on mounds of data. It could be a literal gold mine in terms of what you've got in the data. But if you're not understanding that, if you've not, you know, got your pickaxe out and started mining into that, you know, you won't be able to find the diamonds underneath that, you know. So therefore, when we start to consider what we've got from the available in Microsoft Azure, we can start to streamline that process for us. When we think about what's happening with Power Platform and in particular around the licensing cost changes, you know, some of us may be feeling the burden around the changes around the storage model and, you know, increased costs as a result of that. You know, so from you know, when we're thinking, you know, okay, from a cost effective point of view, we're trying to be cost efficient. We need to start focusing a lot more, okay, well, data are we holding in the Dataverse in Dynamics 365? Do we need to potentially lift and shift that out into the application once it's sort of past its use by date? Those sort of questions are coming more and more to the front these days as a result of, licensing, API limits and things like that. And finally, typically you're using Dataverse, let's say, for one purpose. Traditionally, that may be CRM. It could be a bit wider these days. It could be sales service, could be, project service, field service, all that sort of stuff. But effectively, Dataverse or Dynamics 365 is just one data plank in your organization. So really, when you start to think about moving it out into Azure, that's when you can start to do what I spoke about earlier, bringing in the other data sources, combining, merging, most importantly, enhancing the data, so you can ultimately get the most mileage out of it. And the benefit for us as well is that, Microsoft make it actually pretty easy for us to get our data out into Azure, so we can start doing some stuff with it. Traditionally, we've had the Azure Data Export Service, which we can use to get stuff out into a SQL database. But now we can actually use tools such as the Data Lake Export to start doing big data processing on our data. So if the tools are there, we owe it to ourselves to at least give it a try and see what we can do with that. So these are some of the reasons why I think you should be considering where Azure fits in, and ultimately, why you should be considering it in the first place. So in terms of what we got in the Azure Stack from a technology standpoint, what we're going to show you today is listed on this slide just here. You've got everything ranging from the ability of being able to store your data, potentially at low cost, so good for archival purposes. You can store using Azure storage. You can store things in table storage. You can in pure blob storage. There's a variety of different ways in which you can store your data, and it's ultimately going to be scalable and flexible to your needs. For the actual process of moving and lifting and shifting data, back 5-10 years ago, we typically need to crack open SQL Server integration services, write a couple of DTSX packages, and that handle that all for us. These days, we've got some really rich capability as part of Azure Data Factory that gives us very near, if not total, feature parity with SSIS. And if you are wedded to your packages for whatever reason, then good news, you can bring those into Data Factory and actually reuse those in the cloud first world. A data lake store, as we mentioned already, this is when we wanted to push data out, for our sort of big data analytics solutions. So we've got the ability of being able to export Dataverse data out into Data Lake. We typically then want to connect that up using tools such as, let's say, Databricks or HD Insight or things like that to start getting some processing, some big data and analytics, machine learning type activities running against that. From a data warehousing point of view, in the past, you may have used just box standard SQL Server and just modeled out your database, to account for that with your dimension fact tables, star schemas, and all that good stuff. These days, you've now got something called Azure Synapse Analytics, which is now an almost infinitely scalable data warehousing solution that looks and acts like SQL Server, but actually, in terms of how it's storing your data and scaling things up to suit your particular reporting needs, it's a very elastic solution and one which really you should be considering if you're doing any type of data warehousing. And finally, and we're going to jump into this part of the demo, when you need to start doing, running very data intensive applications, so for example, spinning up, let's say, 6 virtual machines to process through, 1 trillion records, do all this different sort of like molding, shaping, and adding to the data. Databricks comes to the rescue here. You can very easily deploy out these managed clusters of data. It manages it all for you behind the scenes. You don't have to spin up a virtual machine each time that you need to process data. And really, again, this is start to do some really heavy lifting and processing of your data, or maybe look at things such as a machine learning solution or something like that. So I think all well and good talking about it, but I think we want to see it in action. We want to see what we can actually do with these solutions. So what we're going to do today is we're going to give you sort of an end-to-end demo. We're going to bring together all the various components that we've spoken about so far. So whether it's our common data service, I missed that one on the slides, should be Dataverse. We're going to get the data out into Azure, and we're going to use all the solutions here in this diagram. And as part of this, we're going to bring in some useful information from the Company's House API, and we're going to use this to start enriching account level data that we've got stored in our Dataverse deployment. So in terms of how the process looks from end to end, we would have an account that's in our Dataverse instance. Database Export gets this out into Azure for us. We then use Azure Data Factory to load the data in, bring it in our various different tools, transform the data using Databricks. The output of that data, our enriched data set, is exported out into Synapse Analytics. And then finally, we've got a nice little Power BI dashboard that we can use to consume that data and hopefully generate some, well, certainly what we found, some interesting insights, things that maybe you don't expect out of your data as a result of bringing in the Company's House API. Okay, so at this point then, I am going to stop sharing my screen and I'm going to hand over to Mark, who's going to take us through the first part of the demo. Over to you, Mark.
Thank you. Struggling to find my unmute button. Right, so yes, our journey here today starts off with in CDS in Dataverse with some standard account records. So we've got a few thousand account records in here. Relatively simple example here. And I want to do some analysis on this. I want to try and figure out who are my good customers, how can I go about trying to find some more customers to try and grow my business. So I've got a bunch of records that look kind of like this, and I want to be able to use some of these other tools. So as Joe mentioned, one of the first sort of core building blocks of this whole Azure data platform is Azure Data Lake. This is the sort of central storage location that all these different tools can use to share data between each other. So I need to get this data out into Data Lake to start with. And thankfully that's made very simple for me now. So if we have a look in the Maker portal, down the left hand side, there's this option here, Export to Data Lake. And this gives you a very simple process to connect to a data lake that you've already created within Azure, link to that, and then just pick and choose which entities you want to export. So once you've got that link made up, you can just go through here and pick the different tables now that we want to export into Data Lake. This is kind of an all or nothing thing. You can't choose which records within there you want to export. You can't choose which columns you want to export. You just get the entire account table. Now, this kind of assuming that you've got a data lake. So how did you go about creating a data lake? What is a data lake? It can sound a bit intimidating if you're coming to it from the outside. It sounds like some strange data science thing that you need a PhD to be able to understand. It's a data store. That's all it is. It's a specialized version of the Azure storage account, which has been around since the very start of Azure. And if you can imagine in a regular storage account, you can go and put files in there. They're called blobs. And each blob has got a name. If you want to try and organize those files into directories, directories doesn't really exist in blob storage. It's just a kind of naming convention. If you want 10 files in the same directory, you just name all 10 files to have the same prefix / whatever. Data Lake kind of makes those directories a real thing. It's just a tick box that you enable while you're going to create your storage account. If you enable the hierarchical structure, hierarchical folder structure, I can't remember quite what it's called, something like that. If you enable that option while you're going through the process of creating a regular storage account, magically you've got a data lake. That's all it is. Priced very slightly differently, but it's very similar price to standard file storage. So it's not a really scary thing. It's just got a cool name. So what does that look like? So after we've created that, it's got to go through and do an initial sync to pull our data down into the data lake. So if we jump across into the Azure portal, you'll see here we've got 2 storage accounts. One of these is set up as a data lake, one isn't, but they are exactly the same thing as far as the type of resource you're creating within Azure. And the one that's a data lake, I can go across into here. And now it's completed doing the sync. I can see a bunch of files and folders within this storage container. I've got a folder for account, I've got a folder for contact, and there's some config stuff that it stores in here to make the process work. So we'll do an initial sync, and then roughly hourly, I think, as changes happen within Dataverse, it will come and refresh the data in the data lake. So it's not real time, but it's pretty close for enough for analytical workloads. So this is being stored in what's called the common data model format, which is different to the common data service. It's just a file storage structure. So we've got a JSON file which describes some metadata, and if you actually drill down into these, we've actually just got CSV files here which actually store the data. And you can go and have a poke around in these, try and understand the raw data. But typically you would use it using something that understands this common data model format, can interpret this JSON file, and it tells it how to go and load in all the data. So at the same time, so we've got that data from Dataverse, but I've also got a regular storage account over here, to which I've extracted a recent copy of the company's house data. So this is free open data you can go and download from Company's House. You can get a list of all the active companies and a bunch of attributes about them: their name, company registration number, date they were incorporated, their address, SIC code, classifications, things like this. So there's about 4.7 million records in that. So that's not something that you want to actually load into your Dataverse, because as Joe mentioned, you're going to get absolutely killed on storage costs for that sort of thing. And you don't need it in there. It's not transactional data. It's reference data that you might want to use to try and do this analysis, but you don't need it day to day actually sitting inside your CRM. So this is where it really makes sense storing that as in a more appropriate storage location, and we'll merge the two data sets together as we need to. So I've got one file which is just a CSV file here of all the company's house data. I've got this more complex common data model format. I need to bring these two data sets together to try and make some sense out of what we've got. So the starting point for that is Azure Data Factory, which again is something that you can just go and create within the Azure Portal. Actually building up our data factory. So it's a very sort of graphical data flow interface here. So you see the data moves from the left-hand side to the right-hand side. I've got two data sources here. I've got my CDS accounts, again, created it before any name changes. So this will load in from our data lake account. You just point it to that same account and set up a few options to say where exactly is it that it's going to be loading this data from. So this is just the name of that container that Power Platform actually created for us automatically as part of setting up the link to Data Lake. The key bit here that you have to change if you want to load in a common data model format that's been exported from Power Platform is this metadata format. So common data model has got two different formats. It's got this manifest format, which is the more modern one. It's where things are moving to. Power Platform currently produces it in this older model.json format. I believe this is going to change at some point, maybe early next year as part of the Wave 2 release. But at the moment, it's still in this format here. So this just sort of points us to where all that data is stored. But remember, we've got accounts and contacts in here. So lastly, I just need to tell it that I want to load in the account data. Then it will automatically pick up the schema of type in all these things. It's automatically picked up these 191 columns that are in the Dataverse account object by default. That's all just been pulled through from that JSON metadata, and I can just preview that in here as well, just to make sure that it's loading in kind of what I expect. Any second now. So while I'm waiting for that to run, while you're authoring this, it's very helpful to have this option up here turned on, this data flow debug. This gives us some compute power behind the scenes to actually run these little previews and to be able to pull in the metadata, everything. So it's useful to have that on. It should automatically turn itself back off again so you don't get cost a fortune. This obviously isn't working too well here. So I'm going to move on. Idea is here we should just be able to see a preview of the first 100 rows. Oh, there we go. Just need a little bit longer. So we can just have a quick look in here to see, does this data look right? Have I loaded it in the right place? Is it the sort of data I'd expect? It's useful to check these things before you get too far into the rest of the process. Otherwise, you can spend hours going down a bit of a rabbit hole if things aren't working further down the process. Make sure the data is right to start with. So you see there's an awful lot of things here that are just null because there's just so many columns in here by default. but hopefully somewhere in here I should be able to see a company name. There we go. That looks like a company name field. So I can see that, hopefully if that's called the name, I'll be happy that this has pulled everything in as I would expect. There we go, yeah, name. Fantastic. So similar idea with the company's house data set. So this is just pulling in the few thousand records from Dataverse, but this I want to pull in this 4.7 million records from company's house. It's a very similar idea here. I just got to point it to where that CSV file lives in the Azure storage account. Just give it a few options here to say if it's split over multiple files, which files is it that it should be looking at. In this case, it's just in one file, so I've just been able to tell it that. And again, I can go and preview that, and we can have a quick look at what that data is going to look like. So one of the columns I'm expecting to see in here is the SIC code. So if you're not familiar with that, that's a 5-digit code that each company sort of self-reports to company's house to say what sort of industry is it that it's in. As you can see here, some people have some really crazy company names. Love to try and explain on the phone what that company's called. But you see here, we've got some sort of basic information about who the company is, where it is. And if I can just scroll across here, hopefully we can see those industry codes. So you can see these codes here. So we've got 5 digits and descriptive text to say what industry is it that each of these companies are mainly in. And we can report a few different ones, but this should be their primary area of business. Now, SIC codes are hierarchical. So you can keep on stripping numbers off the right-hand side, and they still have a meaning, and they're just more generic. So you might have some numbers here which mean restaurants, and then you can drill down an extra digit and it tells you whether it's a takeaway, and then you drill down an extra digit, it might tell you what sort. So as part of this data flow, I want to try and generate from the 5-digit SIC codes, I want to generate those more high-level ones as well. So I've got those available to me for doing more analysis on. So as part of this data flow, now I've got this data loaded in, I can apply some transformations on it. So in this case, I'm going to create some derived columns, and I can create these just using some kind of Excel-like expressions here to say I just want to take the first 2 characters, I want to take the first 3 characters, I want to take the first 4 characters, and put each of those into a column which I can use throughout the rest of the data flow. Next thing I want to do is I want to join this data to my Dataverse data. So thankfully they've both got a nice easy key on it, which is the account number in Dataverse in CDS is the company's house registration number. So I've got a nice easy key to join those 2 together. So in this case, I want to do a left outer join. That's going to keep all my data from my from the company's house data, which is actually now coming from this high-level SIC filtered computed column node. It's going to keep all the data from that, and it's going to add on columns from my Dataverse data where there's a match. So I should again get that 4.7 million records coming out of it. Some of them will have extra data on that it's appended from the Dataverse data, some won't where there isn't a match. Now with this I want to do 2 things. Firstly, I'm going to dump that out to a file. In this case, I'm going to put it out to another data lake folder again. And that's going to just be the full raw data that I can use for analysis elsewhere. But it's kind of hard to look at 4.7 million records and see whether you've got it right or not. So at the same time, I'm going to apply another transformation to the same output data. And this is just going to do a few aggregations. So it's just going to say, group by that SIC code. And for each SIC code, tell me what's the total revenue that I've gained from my in my Dataverse records, and how many matches do I have from my Dataverse records. And that's just going to be a simple CSV file that again I can store out to a data storage account. So it's quite a simple data flow, processing a massive amount of data. It runs in, I don't know, it probably takes a few minutes to actually start up the compute behind the scenes. It takes a few more minutes to run through. But then I can shut down all that compute and it's not costing me any more money, which is fantastic. So once that's all run through, you can actually have a look at the results of that over here. So this is that full data set that is dumped out to the data lake storage account. And you can see here that's several gigabytes worth of data that I'm putting out there. And it's split across multiple files. So whenever I need to load this in, I just need to make sure I'm loading in all the CSV files from this same location. And at the same time, we've also got this aggregate data set as well. So I can just open that. I can see that quickly in Excel. Again, it just gives me an opportunity for a quick sanity check. So I can, for example, sort this. So I can see that I've got some matches here across all sorts of different SIC codes. And I've got revenue being added up. I've got total numbers of accounts in each of those SIC codes. So I've obviously got some that's more popular, some that are less popular. And probably if I go down here, there's lots that aren't matched at all, just because there's so many of them. Yeah, so I don't have any advertising companies. Okay, so I've got some data out of Dataverse into a data lake. I've managed to process that data with Data Factory and push it back in again. Now I want to actually do some more analysis on it. And this is where it starts getting a bit more codey for this example. I'm going to move over to Databricks. So Databricks is it's a data compute platform. It's built on Apache Spark, and you can use it from either Python or Scala languages. So I'm actually writing Python here to interact with my data. Now, this can be, obviously, there's a bit of a jump up here from pointing and clicking around the Maker portal to be able to write Python code to go and interpret your data. This isn't going to be for everybody, but there is a lot of power here if you want to use it. You can get this to do really simple things. You can get it to do automated things as part of one of your Azure Data Factory data flows. You can call out to Databricks and get it to do little bits of compute where there isn't a built-in thing that you can add into a data flow to just do it for you if you want something a little bit bespoke. But you can also do it much more interactively to just go and explore your data and get an idea of what it looks like and maybe then drive some decisions about how you deal with your data going forwards. So if I just set this workbook running here, it's a whole bunch of steps and we can take it through one by one to get it running to start with. So again, this is all nice and pay-as-you-go stuff. There is some compute behind the scenes. You pay for some virtual machines to actually run your queries on, but you can get it to automatically stop as soon as you're not using them. So you can do some really powerful stuff here, maybe pay for an hour's worth of compute time. It's cost you probably less than a coffee in your local coffee shop, and you've processed some really clever stuff. So to talk you through what we're doing here, so we're reading in this combined data that Data Factory's produced for us. So this magic string here is basically telling it to connect to the Azure Data Lake storage. So this is where putting the data in Data Lake starts to come into its own, because it does become this single point that so many of these tools can all connect into. So we've got Data Factory connecting to it. Now we've got Databricks connecting into it, and there's plenty of others as well. So it's just this common place to put all this data. So I'm loading in all those CSV files that we had a quick look at. I take a quick look again, just a quick sanity check that it seems to have loaded in that data right. And you might notice some of the names here looking familiar. Looks like things are in the right columns. There are, again, a lot of columns now. There was best part of 200 coming from Dataverse. There was another 50 something coming from Company's House itself. So let's just filter those down and get some ones that we're interested in. So we've definitely got the SIC code in the column we're expecting. Now I've got a feeling here there's some relationship based on that aggregate Excel file I had a quick look at. There seems to be some relationship between SIC code and what a company's worth. So I want to do a bit more investigation into that. So first thing we're going to do, we're going to filter it down to ones that have a SIC code and have got some revenue. So most analysis basically doesn't work very well if you've got things with missing values in. So to get this to work today, I'm just going to remove all the ones that don't have a value in either of those two fields, which is what I'm trying to correlate the revenue and the SIT code. Where I really want to get to is, given a SIT code, can I predict whether this is going to be a good account or not? And you can maybe use that as part of a scoring model if you get a new prospect come along, or even if you want to go out and apply that and go and find some new prospects yourself. So now I've got my filter data set. I want to just create a simple flag on it. Is a customer good or bad? Just a 1 or a 0. And in this case, I'm going to say if the revenue from this customer is over £10,000 in the year, then it's a good customer. If it's less than that, it's a bad customer. I want people that are going to spend over £10,000 with me. So this bit here is just creating that calculated field based on that revenue data coming from Dataverse. I can see I've got just shy of 5,000 accounts in my filter data set. So these are the ones that I've got data to work with. And I'm going to try and produce a machine learning model here to try and do that prediction for me. So a key concept when you're building a model like this is to split your data set into a training data set and a testing data set. I'm going to take 80% of my data here for doing the training with, and I'm going to use the remaining 20% to test it and see how good it is. This tends to be a very iterative process. It won't be right first time. You'll need to tweak all the parameters, you'll need to tweak the algorithms, you need to tweak the inputs to get everything just right so that it actually makes some useful predictions. So I'm going to split this once, and then to be honest, I've spent far too long trying to get these next bits actually working right for this demo. But from this, everything up to this point I can reuse, and then all these other bits from now on, you can go around as many times as you want and keep rerunning just the little bits of this this workbook that you need until you get something that's actually working. So again, a quick sanity check before I get too far down that rabbit hole. What does my label look like? So the label should be 0 for my bad accounts and 1 for a good account. You can see here I've got revenue of 0, 9,000. These are all apparently bad accounts. If I scroll down, hopefully, yeah, there was one that's flagged as a good account because it's got a revenue of £10,100. So this bit's working so far. So now we get into some of the more machine learning stuff. So I've got a SIT code, that's a bit of text, and most machine learning models don't really work very well with text. They like to work with numbers. So what we're doing here basically is trying to create some numbers based on the SIT code, just some automated encoding, and this will produce some seemingly random numbers behind the scenes. So given a SIT code, assign that SIT code a unique number. Everything with the same number refers back to the same SIT code, but there's no real relationship between those numbers. One isn't greater than the other, they're just different numbers. That's what that's trying to get to there. Then we're going to go for kind of a standard machine learning technique, which is logistic regression. And this is going to try and infer that label, that 1 or a 0, based on the input I'm giving it, which is this numeric version of the SIT code. So we're building up a bit of a pipeline again here of different stages the data's got to flow through. It's got to flow through all the SIT code encoding, and it's got to flow through this logistic regression algorithm. So we fit all that together in a pipeline, pass through the training data to produce the model, and then pass the testing data through that model to generate some predictions. So now we've got some predictions. In fact, we can go and have a look at some of them. I just put in a thing here, so I'm going to display my predictions data set. So we've got some here. This is all the data that came in, and then hopefully if I scroll all the way across, I've got a prediction here. So this is predicting that these ones aren't going to be good accounts. And there was some here that's predicting that it is going to be a good account. So this is what that machine learning model is really doing. At the end of the day, it's producing this prediction column here. So how good are these predictions? How can we tell that? So this is what that 20% testing data is all about. We already know what the answer should be for those 20%. But now we need to compare what we know it to be against what the prediction is, and then we can measure how how well our model is performing. And there's some things built in here to do this for us as well. There's some code here to evaluate these predictions for us. And this is it can produce various different statistics, but the one I'm looking at here is this area under the curve of 97%. What this is essentially saying is it's going to get the right answer about 97% of the time, which is fantastic. We can visualize that. If you can imagine, as we get data right, the line goes up. As we use up data, it goes across. If I was to guess randomly those ones or zeros, I would get this red dashed line across the middle. I'd be getting some right, I'd be getting some wrong. What this model is actually performing is this blue line here. So we very quickly get a lot of data right. And then this last tiny little bit between our 97% and the 100% is where we're getting stuff wrong. So hopefully if you get a curve that's above that red dashed line, then it's performing better than a random guess. If you get it actually going below, then you might as well have not bothered in the first place. So now I've got a model, and I could actually save this model out at this point, and then I could apply it in different ways. So maybe, say, if you got a new lead coming in, you could apply that model to that lead and say, how well performing do we think this is going to be? If we think it's going to be a good performer, if we think it's going to go over that £10,000 threshold, maybe I want to pass it on to my best salespeople as some sort of key account management situation. Otherwise, maybe it goes to just a general client services team. Otherwise, we could apply that model to the records in this company's house data set that we don't have already. Go and find me some new prospects. Find me the ones that have got the highest probability of hitting that £10,000 mark, and go out and actively target them. So you'd be glad to know that's the end of the in-depth code for today, I think. I'm going to pass back to Joe to try and produce us some nice, pretty charts of this.
Thanks, Mark. Yeah, there's a couple of brains have exploded, I think, over that. There was just one question which about notebooks. Am I right in saying that there's no Intellisense support within Databricks for Intellisense? So as you write in the code, it obviously highlights and all that good stuff.
Yeah, so there's no Intellisense. It will show up errors as you run it, so you don't have to run this entire thing end to end, only to find out that you had a problem at the start. There is an awful lot of content out there on the internet to try and get you started. A lot of this is kind of pieced together from bits that you could quite easily find from examples and documentation. There's a lot of people out there using this, that you can go and get examples from. If Stack Overflow is your friend, there is a lot out there, but no, there isn't the Intellisense as you type.
Good stuff. Thanks for that. Okay, yep. So just to finish off then, we're going to show you how you can take the output of all the clever super stuff that Mark's done, get it into maybe a much more structured way, and then present it via sort of, a nice little reporting dashboard. So we're back in Data Factory now, and the first thing we need to do is actually get it out into a structured database. So what we've got on here is just a pipeline. It's going to be taking those CSV files that Mark showed us earlier, and just basically just copy them into Azure Synapse Analytics. So all we do there is just define our source there, company's house appended, link it up to our database. And in this case, what we're doing is we're importing into staging tables first, and then we're just going to do a merge script to be able to get it into our primary tables. So those two tasks there handle that bit for us. Then we have a store procedure for each one to be able to just run that, get the data in there, and only update when there's been a change to our data, and then insert or update existing values and all that stuff. So with that done, then we can then jump across into SQL Server Management Studio. So this up here, it's a bit of a suspicious one. It looks and feels like a SQL Server database, SQL Server 12. Yeah, this is SQL Server I'm connected to. Looks all good. Oh, hang on, it's a little bit different there. You've got a different logo there. The tables look a little bit different. So this is the general experience that you'll find. You'll be able to do what you'd expect a typical SQL Server database to do with Synapse Analytics, but you're not actually connected to a database engine here. You're connected to instead a compute node, and then behind the scenes, in terms of how the data is stored, it's actually using Azure storage. And based on how you've configured your tables and your index settings will then dictate how that data is stored within the back end. So you can see here, I've got a couple of tables on here. If I just show you some of the scripts on here, that have been used to create this. So for example, if you have a look at this create table script here, it's a pretty standard SQL statement here, creating all the fields with a schema and stuff like that. Down here is where we get some specific Synapse Analytics options down here. So in this case, we're saying, okay, we want our distribution type to be round robin. This is going to change how the data is sort of split out. And then the index type that we're using is heap. So with these options on here, we're optimizing this particular table for being just a temporary throwaway table where we just load data in, chuck it out again, truncate it, stuff like that. Whereas for our actual main table, a little bit further down, we're actually going to be using a hash distribution method based on the company number. So this will make sure that we've got data that's got the same company number is stored within the same effectively storage account behind the scenes. And then finally, we're using a cluster column store index. That's going to provide us with the most effective compression and searchability for our data as well. So all those statements there sort of create that for us. And then all we then need to do is we use our favorite go-to reporting tool, Power BI, to basically pull that data in, much in the same way as if we would do from a SQL Server database. So what we've got here is just a very simple, basic dashboard. There's not been much work here to be able to sort of build this sort of out. But in terms of some of the insights we can actually start to generate, we were looking at this yesterday and we're actually quite interested in terms of what we could see. So for example, we can see that actually, okay, in terms of revenue by SIT code, IT consultancy ranks up there. That probably makes sense, you know, with charging people out at ridiculous day rates and stuff like that. So we must be earning a killing off that, I would have thought. Dive down a little bit deeper, we can see, okay, well, business and domestic support software development, that's got a fairly big chunk there as well. We can get some interesting stats as well. Okay, so number of companies incorporated this year, according to the company's house data set, that's around 600,000 companies. So, you know, given it's been COVID and a bit of a rough year, it's obviously good to see that, you know, businesses are still moving on a bit forward from there. And then down here, we can actually see, because we are putting in the address data, we just pulled in the postcode on here. And what this is actually telling us, and we have to double check this and look into it, is that actually a lot of companies have actually got foreign addresses. So although it's, you know, allegedly a British company, in this case, we can see we've got addresses here out in France. These are French zip codes that are being returned on there. So actually, you know, we might potentially, we're talking about sending this across to HMRC because maybe we could use this to actually, you know, grasp a few non-doms, you know, get them to pay their tax correctly and all that good stuff. You know, so again, it's when you can start to use a tool like Power BI in conjunction with all the really good stuff that Mark has done with the data, is that we can start to get some really good insights. So for example, decomposition tree here, we can use to drill down into the data, see how it's all sort of variously sort of built up. And as I say, the dashboard can then be set just to update as we're drilling down. So definitely a lot of really good things that we can start to do with Azure and the Dataverse to enrich our data and get things really melded together and you know, discover some things that we really didn't think were possible before. Okay, so I'm just conscious we've only got 15 minutes left. So what I'm going to do is I'm just going to return to the slides quickly, just to wrap up really.
Joe?
Yeah, sure.
Just before we move on, so would you like to comment on, so there's a question about whether Power BI can load in the data directly without having to go via Synapse. So yes, it can, but do you want to comment on where putting the data into Synapse Analytics gives you benefit rather than just dumping it straight into Power BI?
So for me, the key benefit is direct query. So if you need that real-time view of the data, you don't want to rely on import mode for your data. I believe, unless I'm mistaken, with storage accounts, it's import mode only for your data. So if you need that real-time view and you want to be using a tool that's really geared for handling, you know, performance-intensive queries, that's when you'd use Synapse Analytics.
I think the key thing here is for our demo, we've got 5,000 accounts. Yeah, we've got 4 million companies, but we're really not stressing the system at this point. But where you're getting into the proper big data territory, then yeah, that's where I think you're going to see that main advantage of having all this distributed compute as part of Synapse Analytics. You can split the compute over 60 servers or something. So yeah, they're talking about serious data volumes here.
This is it. And you know, from a personal preference standpoint, I like working with data when it's in SQL. It's, you know, force of habit or just familiar. I'm sure there's other sort of BI reporting developers who probably feel the same. So, you give them a SQL database to work with, they're going to do more with it as compared to, okay, here's a storage account and CSVs. You'll probably just make them barf or cringe, perhaps. Okay, so we've covered a lot today. It's been a bit of a whistle-stop tour, but there is actually more in the Azure Stack which we haven't discussed today. So I just want to touch upon those quickly and just talk about, okay, why you might want to consider using those in other areas if it came to it. So Cosmos DB is actually a pretty huge area. It's one that personally I need to investigate more, because it's really all about providing you with a globally scalable database service that can support your traditional SQL type data, but also support documents and other NoSQL type data stores as well. And the key benefit that you're getting with Cosmos is being able to globally distribute your data across different geographies. You're able to set in terms of your concurrency levels around that, whether transactions always persist or not. It really is all about providing that. I think Xbox Live or one of the major gaming services uses Cosmos DB along with other ones as well. So it is, again, really when you need to go global with your data solution, Cosmos DB is going to be your first one to sort of look at. It's worth mentioning it's perhaps arguably less important these days, but still, I guess the mainstay, Azure SQL, good old SQL Server, is there in the cloud as a fully managed service. And it's a really nice experience. You don't have to worry about managing servers, managing all the different baggage that comes with that. You just get a SQL Server and a SQL database. Lovely stuff. Beyond that, you're particularly concerned about your vendor choice as well. There are also options to look at maybe MySQL database, MariaDB, or PostgreSQL again. And the key thing with that is that they're offered managed as well. So again, not having to worry about managing servers. Anything you can do these days to avoid that dependency, to avoid having to subject yourself really to really low level server management, I think is really important. It's going to make you a lot more agile, I think. Stream analytics. So this is great for when you've got IoT type data, streaming data that's constantly updated behind the scenes. It's potentially a good candidate to use for data lake storage perhaps as well, depending on the volume of data that's being chucked out. It really just depends in terms of what your preference is. You've got a nice tool there with a SQL-like querying language that can potentially be used to address that need. Databricks, you wanted to use something maybe that's more aligned to tools such as Hadoop, Apache Spark. You've got Azure HD Insight. It addresses the same type of scenarios that Databricks do. Databricks, from my own personal preference, is probably a little bit better, I tend to find. And then finally, if you're looking for a service in which you can try and sort of just, I guess, really just understand the data, what we've shown today, there's lots of different data flying about left, right, and center, potential privacy or GDPR concerns that could arise as part of that. By using Azure Data Catalog, you can hopefully start to, automatically document the various different data stores that you've got, annotate those appropriately so the organization knows what it is and what it's doing, and ultimately make sure that from a compliance standpoint, you're not going to fall foul of anything. So as you can see, there's a lot on the Azure Stack. It's impossible to cover it in a single session, but hopefully what we've done today is shown you some of the easy ways, the quick wins that you can get started with it. So in closing then, I think I'd go back to what I say earlier in terms of, it's really easy from a data first standpoint to get started with Azure. Microsoft give us the tools there to be able to get things exported out into there and then start to use them with the various different services. And the good thing as well is that you're not necessarily having to break your bank account here. So what we've shown today is, numerous different enterprise, processing integration type options. We've been able to just sort of execute those on demand. We're paying only for what we want. And the bill at the end of the day will only just be, the price of a cup of coffee or two. So potentially if you just need to do that ad hoc type processing, maybe once per evening, your total bill each month isn't going to be particularly huge. And ultimately what we're getting to here is we're hopefully trying to get some really good, fresh new insights from your Dataverse Dynamics 365 data at the back end of it. And really when we're looking at tools, for example, such as Data Factory, what they can offer you from an ETL standpoint really does outmatch some of the other solutions that may be available. So whether it's SSIS or maybe tools such as Kingsway Soft or Scribe Online, I think today you've got a really cost-effective solution there that allows you to address those needs, have that reusability across maybe different projects or different deployments and things like that. And it's a really great tool. It's one that I talk about it quite a lot because I think it's really great. Anything you'd like to add, Mark, just on any of that?
I think, as you said, there is a massive amount out there, and no one really can know it all. There's just far too much there. So I think my key thing is, we've given you a very brief overview of lots of it. Not all of it's going to be applicable to everybody, but have a go, because some of it will be applicable to all of you almost as certainly.
Absolutely. Okay, so I think have we got time for questions still, Matt? Or
a few minutes. I'll look out in a few minutes, but if anyone's questions, feel free to chuck them in there. I'll chuck some links in the chat now of where we go next and that sort of stuff. While the questions are waiting to come in, if anybody is still about, can I ask you to unmute your microphone, just give the guys a round of applause and say thank you very much for giving the presentation. So thank you very much.
So just whilst we're waiting for questions, just a reminder as well, make sure you are filling out your feedback forms. I think Matt's just put in the thing in the chat down there. It's really important for both the organisers and the presenters just to know how we've done today, so we can obviously make sure we improve in the future. And there is a really awesome prize on offer. It's looking really nice. So big thanks to Mark and Matt for donating that, I think.
No problem, thank you.
Okay.
Right, I'll tell you what, let me stop the recording. I'm sure you guys can stick around the room for a few more minutes just in case anybody else decides to ask any more questions.
Yeah, absolutely, that's fine.
I am going to politely